everybody, this is Mrs. Lehman from Math with Mrs. Lehman, and I am here today with my first period class. They're still a little sleepy, I think, this time in the morning. Anyway, what we're going to do today is learn about least common multiple. We just finished up lessons on greatest common factor, so the kids had some homework about using a factor tree and then writing the prime factorization. So we're going to spend a few minutes to go over this, and then we'll move into LCM, or least common multiple. All right, so a factor tree is something we use to break a number down into its prime factorization. So the first one was an example that they gave to you, and you would write 2 times 2 times 11 equals 44. Okay, so that would be the prime factorization of 44 because it's broken down into only prime factors. Okay, so the next one was 90. We're going to break that down into, you could have either done 9 times 10, you could have done 2 times 45. Right, you have some options there. So I'm just going to use 2 times 45. Did anyone else choose that one? 2 times 45, right? Did most people pick 9 times 10? Who would pick 9 times 10? Vast majority of children. So I'm going to change this to 9 times 10. All right, so 9 times 10, that would break down into 3 times 3, both prime. You can't touch those, right? 10 is also composite, so we are going to break that down into 2 times 5, both of which are prime numbers. So the key to doing this also is putting them in order from least to greatest. So 2 times 3 times 3 times 5 equals 90. Okay? Another way you could have written this, if you want to get fancy, is 2 times 3 squared times 5 equals 90. Are there any questions on that? Who here had that on their paper? Woohoo! Very good. Nice job, guys. All right, 48. How do we break this down? Who can tell me how they broke it down? Jaden?
2 and 24.
Okay, anyone else do 2 and 24? A few kids. Anyone do 6 times 8? All right, it seems like a pretty close tie, so I'm just going to use what Jaden said. 2 times 24. All right, which number, is there a number here that's prime, I should say? Which number? 2 is prime. You can't touch that. You can't break it down. 24, what can we break that down into? Jay?
2 to 12.
2 times 12, very good. So we're going to break that down. 12 is going to be broken down into, I'll bring that 2 down. What can that be broken into? Loretta, nice and loud.
2 and 6.
Very good. 2 times 6. 6 is composite, so you can break that down further. You're continuing to bring down all the prime numbers because each row will multiply to give you what if you've done it correctly? 48. Very good. All right, so this is 2 times 3, both of which are prime. You got to bring down this 2, bring down this 2, and bring down this 2. All right, so the prime factor is the prime factorization of that is 2 times 2 times 2. Was there 4 of those? Times 2 times 3, and that equals 48. So you can't write that far over, Mrs. Lehman. That's what that is. I can do this on here. You can't do that on your paper. All right. So can anyone tell me how to write that with exponents? What do you think, Miguel?
2 to the 4th power times 3.
Ooh, you guys are good. 2 to the 4th power times 3 equals 48. Who had either of those answers? You guys, I am so proud of you. Nice work. All right, 204. Now, here's where it gets really beneficial to use a factor tree. That's a big number, right? Fairly big, compared to something like 24, 48, 90 even. And it's not a whole lot bigger than 90. Let's over double. Anyway. We'll move forward. All right, so 204, we notice that that's what type of number, even or odd? Even. So whenever you have an even number, you can divide it by 2, right? So 2 goes into 104 102 times. That's also even, so we can break that down. What can we break that down to, Camilla? Nice and loud. 2 times 51. Very good. All right, bring that 2 down. Now, is 51 prime or composite? It is not prime. It is composite. Does anyone know what number goes into 51? Camilla again. 3 times 17. Very good. So 3 and 17 are both prime, but 51 is not. Okay? So the answer to this one was 2 times 2 times 3 times 17 equals 204. Did anyone get that? Few people dug a little deeper. 51 probably got a few of you. Nice job if you got that. Who here had 2 times 2 times 51 because they missed the fact that 51 was prime. Okay. So if you run into a number like that, it's not going to hurt to try a few, easy factors to see if they work. All right, 400. Let's break that down into 4 times 100. Okay? Did anyone else do that? All right, cool. Some people do 2 times 200. All right? Looks like a few people did that too. All right, so 4 can break down into 2 times 2, both of which are prime. 100 can break down into a few different things. I'm going to do 2 times 50. All right? 50 can break down into 2 times 25. Bring down all of these 2's. And 25 can break down into 5 times 5. So the prime factorization of this is going to have a lot of 2's in it. All right, so 2 times 2, what do we have, 4 of those? Times 2 times 2 times 5 equals 400. So we have 2 to the what power here? Addie, nice and loud? Very good. 2 to the 4th power, oops, not equals, times 5 to the what power? Loretta? Very good. So 5 squared, or 5 to the 2nd power, equals 400. Who had either of those answers? All right, nice job. Okay, 56. What math fact do we know that will multiply to give us 56? Marcel? 8 times 7. Very good. So 7 times 8. Either of those prime? Which one? 7. Can't touch that one. Break this down into 2 times 4. Bring down that 7. And the 4 is going to break down into 2 times 2. Bring down this 2. Bring down this 7. So you have 2 times 2 times 2 times 7 equals 56. Well, how can we write that using exponents? Jayla? Very good. You could say 2 to the 3rd power times 7 or 2 cubed times 7. Very good. All right. So with these next batch of questions, you had to just multiply the numbers out. So they gave you this bottom row, for example. You have to figure out what does it equal. Okay. So 3 times 3 is what? 9 times 11 is 99. So 99 is your answer for that one. The next one, we have 2 times 2, which is 4. 4 times 7, that's 28, right? 28 times 13. So I'm assuming you had to kind of go to the side to do this one, so we're going to go ahead and do that. 3 times 8 is 24. Carry your 2. 3 times 2 is 6. 6 plus 2 is 8. Put a 0 placeholder. 1 times 8 is 8. 1 times 2 is 2. Add those up, and you would get 364. Who got 364? All right, good work. And the last one, we have 2 times 3 times 3 times 3. So 2 times 3 is 6. 6 times 3 times 3. All right, so what is 18 times 3? 54 is your answer. Okay, any questions on that? All right, and lastly at the bottom it says a computer code is based on the prime factorization of 160. Find the prime factorization of 160. So you had to take 160 and break it down like you did all the other ones. So 16 is what I think of when I see 160. So what could we break 160 into? Junia?
280.
2 times 80 would work. Yep, very good. 2 times 80. I use 4 times 40, but if you've done this correctly, will they break down the same? Yes, they will. All right, so 2 times 80 works. 2 is prime. What about 80? What do we call a number that can be broken down further than that? It has more than just the 2 factors. Composite, good. Miguel, what would you do for 80?
40 and 2.
All right, 2 times 40. Again, you have a few different options. Could have picked 8 times 10. All right, and some other ones, but 2 times 2 times 40. Let's break up 40 into 2 times 20. Bring down the 2's, bring down the 2's. All right, 20 can be broken down into 2 times 10. Keep bringing these 2's down every row. And 10 can be broken down into what? 2 times 5, yep. So bring these 2's down. Does it feel like you're writing 2's all the time when you're doing prime factorization? It's a little much sometimes. All right, so 2, 1, 2, 3, 4, 5. We have 5 of those. 2 times 2 times 2 times 2 times 2 times 5. How could we write that with exponents? 2 to the what power? Abby? Very good. 2 to the 5th power times 5 equals 160. All right, the next one, it says the combination for a lock is a 3-digit number. The digits are the prime factors of 42. So again, we have to find the prime factors of 42. We've got to list them from least to greatest. What's the combination? So you have to break down 42. So let's just do 6 times 7. 7's prime. 6, you could do 2 times 3. Bring down that 7. So your combination for the lock is 2, 3, 7, okay? If you wrote it as 2 times 3 times 7, I'm okay with that. I'm going to pause the video for a quick minute, but that is how you do your homework. Okay, now that we're done with that, we're going to work on what we call least common multiple, or LCM. So this lesson in the module covers both greatest common factor and least common multiple. We focused the first few days on greatest common factor. You guys are going to be on page, let me look here, page 34. All right, in your workbooks it's page 34. It's a little different on my version up here, but anyway, either way, it's lesson 18, least common multiple. All right, so least common multiple is a skill like greatest common factor. It has some unique applications, but instead of breaking numbers down into its factors, we are skip counting by 2 numbers, right? And we're seeing where is the first place that they meet. Okay, so I've got an example of when we would use this. So I get my hair trimmed every 4 weeks. Some people would find that excessive, but that's what I do. All right, so every 4 weeks I get my hair trimmed. Now, years ago, I used to work at a pharmacy with a lady named Judy. All right, and Judy, this is a true story. Judy gets her hair trimmed by the same hairdresser every 6 weeks. And one day I was in there and I said, "Oh, hey, Judy, how have you been?" I mean, because it's been years. This was back when I was in college when I worked there. And I was like, you know, happy to run into her. She was getting her hair cut at like 4 or something, and I wasn't going over until 5. So we didn't really run into each other, and she changed her time. So either way, I ran into her, and I was like, "Hey, how have you been?" We chatted for a bit, and I said, "I didn't realize you got your hair cut here." And she goes, "Yeah." I said, "How often do you get your hair cut here?" And she said, "Every 6 weeks." So then she goes, "When will we see each other again? How often do you get your hair cut?" And I said, "Every 4 weeks." So we figured out when the next time we would see each other, when the next time would be based on the least common multiple. So if you would skip count by 6 and 4, what number of weeks will pass before we bump into each other again? Not 24. A lot of kids think you just automatically multiply them, but they actually run into each other before then. When would we run into each other?
12 weeks.
12 weeks. Very good. So how many haircuts would I have gotten in 12 weeks? That would be what? Haircut number what? Coop?
3.
Haircut number 3. Judy would be on haircut number 2. All right, so that is a real life example of least common multiple. They go, "How did you figure that out?" They didn't call me Mrs. Lehman, but how did you figure that out? And I said, "Well, least common multiple." So anyway, legit story. So anytime you're looking at a situation where something, whether it be a schedule, the module gives examples with some gears meeting. Anytime you're dealing with something that goes in a cycle and you're wondering when 2 numbers are going to encounter one another, that's least common multiple, okay? If you were in my classroom right now, you would see something that I made, which I mean I ventured over to the math world and I took this and brought it back with me. So two numbers were jumping along the number line and they happened to meet, and it was like love at first sight. All right, so it's kind of like their first date when they first meet. They're like, oh, do you remember the time we met on the number line? Right? And so they carved it in a tree, LCM. You guys are like, you are insane. That's okay. It'll help you remember. All right, so anyway, let's practice doing this. So really all you do to find least common multiple is you skip count. You keep counting by that number until, and you do the same with the other number until you get the same number, okay? Does that make sense? So we're going to list the multiples of 10 and 12 to find the LCM of, not of 10, of 12 and 18. So we're going to find the 10 multiples of 12. Let me undo that. All right, so 12 and 18 is what we're looking for. So we're going to find multiples of 12, multiples of 18. So let's go ahead and do this. We write 12 like this, and then we're just going to think about this. What's 12 times 1? 12 times 2? 12 times 3? 12 times 4? 12 times 5? Let's stop there and see if we run into anything with 18 before we get a huge long list, right? Because sometimes it'll be a pretty quick meeting. All right, 18. 18 times 1. 18 times 2. This is where we start to go, huh? All right. Add another 18 to that. What are we going to be up to? 54. Good. No meetings yet, right? Add another 18 to that. What would that be? 72. Good. Another 18 would be 90. Good. So you just keep adding that number, right? These are the multiples of it. So let's keep going up here. 60 was our last stop with the multiples of 12. Add 12 to that, Camilla. What are we going to get? 72, yeah. So I'm going to not do the first 10 because if we're looking for the LCM, that's the least, meaning the lowest multiple they have in common. So the first time these numbers meet is at 72, right? No. Oh my gosh! All right, so blooper reel, like I said in the last video. This whole video, this whole channel is a blooper reel. All right, so this is a common multiple. Good catch, guys. What I'm going to circle in red is actually the least common multiple. So the LCM, least common multiple of 12 and 18 is 36. That's the first time they run into each other. And as I mistakenly pointed out, not on purpose, I should say, is the LCM the only time these numbers will meet? Will they meet again, I guess is a better way of asking that. They will meet again, yeah. So they're going to meet at 36 for the first time. Yay. And then they're going to meet at 72. You know what I really feel like doing here? I feel like making this a heart. It's the first time they met. Anyway, I know this video is a little short. I'll try to finish up more with the next class. So I'm going to pause this, and I'll be back with period 2. Okay, so I'm here with period 2 now, and what we're going to do is quickly look at what your homework is tonight. So we are going to be doing these 5 questions for homework on the next page, which is page 35 in your module workbook. All right? So LCM, again, is when you skip count by these numbers, where will they meet? So let's do 9 and 12. Some kids are going to need a separate sheet of paper to do this. If your handwriting is not naturally small or neat, I would recommend using a separate sheet of paper. There's nothing wrong with that. I just want to make sure that this doesn't turn into a word scramble. Okay? So first number we would write here is what? 9, and then 18, 27. What's next? 45. Let's do a few more. 54. Now, I wouldn't recommend doing a ton at once. I would do, we probably went too far. We could just do about 5 and then keep going back and forth. All right, so 12 times 1 is 12 times 2, 12 times 3, 12 times 4. Did they already meet? All right, so we're going to put a heart around their LCM. They celebrate it like an anniversary in the math world. This is that special anniversary where they first met. Now they're going to meet again many times, an infinite number of times actually. Yes, because numbers will keep getting bigger and bigger, right? So this is the first time they meet. This is the least common multiple. So it's a multiple they have in common. It's the smallest one. Okay. Least common multiple means the smallest multiple they have in common. So anyway, that's an example for what you guys have to finish tonight. You have to do 4 more problems. Thank you for watching Math with Mrs. Lehman. I hope you have a great day. Don't forget to subscribe. That was very convincing. If that wasn't a convincing argument to subscribe to this channel, I don't know what was or what is. All right. I gotta go. Bye.